if you haven't watched Glenn Ross, the title is a part of the movie. It's always a very, very famous speech. Oh, A always B, B, P, pair programming. I think when you hear people talk about sync engines all day, you think I'm about to argue this, that your VS Code or your agentic IDE should have another agent that should sync and obviously should edit and send in the documents while you're editing as though it was an AI teammate. Of course, that's going to happen. Of course, we don't have it yet. Of course, the people in this room are going to work very, very hard over the next 5 years to do that. So I'm not here to talk about that because everyone in this room knows that that is the future of where sync and AI is going to be. I'm actually here to argue the other side of sync. The proposal is to put humans back in the loop. I think that a lot of the AI industry that I talk to with my podcast, Latent Space, and my conference, AI Engineer, we are trying to go to the left-hand side of the sort of full self-driving spectrum where we take out the steering wheel. But instead, I'm willing to wager not a single person here has actually sat in one of the Zooxes, although I'm very much hoping to get an invite. A lot of us have sat in Teslas with full self-driving, and it works fine when there's a problem with the AI. We know how to overtake it. It is quite safe. It's not completely safe, but it's quite safe. And I think that's the kind of relationship that we want to have our AI. We want to have the mind meld with the machine and not be replaced by the machine. And I think the people at Sync, actually you have more to do with this than you think. Even though if you don't work in an AI lab, you actually have the right inflection points in terms of the human-computer interaction that you guys actually are at the forefront of this and can control this. So what do I mean by sort of the far side of autonomy? A lot of people in the AI research field are very focused on full autonomy, as they should be, because they're trying to extend the amount of autonomy that people can have. So here's one of the very famous meter charts, and they're speaking at AIE next week, on how much more autonomy over time each model is capable of. Like every model now that you see released is going to tout longer and longer and longer autonomy. You can see Anthropic say that they can go for up to 30 hours. You can see Replit say that they go up to 200 minutes. And obviously, there's no accountability on any of this. There's no benchmarks. The reality was Replit, starts the sheer amount of autonomy starts deleting production data. A lot of the code, a lot of the work that is generated is complete slop. So now 2 engineers can generate the tech debt of 50 engineers. There are actually marketplaces where people are spending a lot of time vibe coding and specializing in fixing the bugs of vibe coding. So here's a marketplace called Vibe Code Fixers. It's a startup, specializing in just fixing the issues created by vibe coders. And I think more concerning for people who are professional developers is you just stop learning. You have this distance between yourself and the code. You don't own it anymore. You don't feel responsibility for it. When you run into trouble, you don't know where to go. So I'm sorry about the cough. Security goes out the window. People build their SaaS using Cursor, and then they get hacked, including people building vibe coding social dating apps where security is very, very important, and obviously leaking millions of people's personal data. So I think we know the issue. I think and then one more insidious issue which I'm going to bring up, which is the illusion of productivity, right? You see the terminal going, and you think wow, I'm being so productive. And a lot of people even run 6, 10, 12 of these at a time. But then Meter, again, measured the difference between people's sort of expected productivity and their actual productivity. Everyone expected themselves to be about 20% more productive. And in fact, they were actually 20% less productive. So I think the reason is really because we give ourselves credit for all the big leaps forward, or we give AI credit for all the big leaps forward, but then we sort of discount it when we have to go fix it, and our productivity decreases. In the total accounting of things, we have to be responsible about all this. Okay, so I'm gonna go back to and this is not a very anti talk, but I think I just want to share with you the conclusion for me working on AI coding over the last few months. Is that basically having human attention, keeping human attention in the loop with AI attention is going to do better than having either of them alone. This is basically called the Centaur thesis in AI, and is basically universally replicated in every single application of human-computer interfaces. there's three main ideas that I've worked on recently that help towards this. And I just want to contribute this. Obviously, this is not like the be-all and end-all things, but I just want to I want to show you inspirations where you can actually bring the human back into the loop. First is the idea of interactive planning. This is something that when I started work on small developer 2 years ago, I actually started to scratch the surface of, but I couldn't really solve it. Devin had this on day one, and this is one of the reasons I joined Cognition. We've all seen non-interactive planning. I mean, who among us has kicked off like a Claude Code session and then the prompt wasn't exactly right, I needed to change it. But you have to either cancel or wait until it's done before you continue, right? Everyone has had this experience. I see a lot of nods. So that's non-interactive planning, right? You have to destructively or interrupt or cancel. And then you also see bad interactive planning. Who among us has kicked off a deep research in ChatGPT and then come back 2 hours later to find that it's just pausing, waiting for your input, right? Also just it's like, nice try, but could you at least try a bit harder, right? I think what you really want is non-interruptive, non-destructive, default yes interactivity. That's what I call interactive planning. That's what I call true interactive planning. I think it's really hard to illustrate without showing you a video, and I don't want to go into a live demo. So I'm very good at abstract visuals, which I hope translates to your mind, right? So non-interactive. So red is human, blue is AI, black is something we'll talk about later. Non-interactive means like the human does something at the prompts, AI goes away to work on it. You realize that you need to modify your prompts because who knows everything that they want to do up front. And then you have to wait until the AI is done, or you have to cancel and interrupt it. Bad interactivity, this is the deep research one, is basically where you have to sort of be on the lookout for the AI to finish, and then realize that you actually have to keep going in order to get stuff done. Good interactive planning is a lot of fast iterations, right? Notice that this overall length is shorter because there's more turns. You get to where you want to go faster. But also you just have more turns back and forth because you're staying in the loop. I think the ideal interactive agent, by the way, this is still not good enough because this is basically still modeling the AI sort of turn taking as sequential. I think basically you want to have simultaneous collaboration on a given document. This is where sync comes in, including multiple parallel agents working on parallelized tasks that hopefully don't conflict with each other. A lot of good work being done here on conflict resolution, a lot of good work here being done on like CRDTs and stuff. But honestly, a lot of work doesn't need any of that. You can just split things up by module, file, subsystem, whatever. And then this is the first idea, is that you actually want interactive planning. You want to keep the human in the loop. They should not go away, right? At least in the planning stage. The second part is something about breaking flow, keeping in flow. The other part of Windsurf, the other part of Cognition, which bought Windsurf, was this idea. We actually looked at the analytics of how much people stay on the session. And so basically the distance between first query and second query, or first action and second action. And if actions took longer than an arbitrary cutoff of, let's say 5 seconds, you're very much likely to not return for a long time because basically they all tabbed away and went to Twitter. So this is what we call the arbitrary flow window. Our estimation, and this is sort of borne out in human-computer research. I found this old paper from 2015 talking about how it's actually correlated with the difficulty of the task, right? Your attention and the probability of you breaking flow is correlated with like how hard you think the task is. Like, are you sitting there waiting to sort of for it to finish this task, or are you're basically firing and forgetting? And basically, our estimation is that it takes roughly it increases 10% every second that passes while you wait for an agent response. So effectively, once an agent response takes up to 10 seconds, you have almost 100% probability that you have broken flow already and you've tabbed away, or you lost context, or your attention is broken. So we really call this, my catchy term for this is the semi-async value of death. Either you want to be super async and long-running background, parallel background, you fire and forget, you can come back the next day. There's no difference between 5 minutes and 30 minutes, great. Or you want to keep within flow and keep the responses flowing because then it's center of attention and you actually can influence the trajectory of the agent very well. And what we're finding is that I used to call this the sync and async divide between agents. I think that's wrong. Actually, commoditized stuff that is well within agent capabilities should be done async and parallel. But the deepest work, the hardest problem, the ones that requires your focus augmented by AI, should be done as fast as possible, as much flow as possible, as deeply as possible, right? So I think that's where sync, part of what syncing means and part of the local first manifesto is that things should respond quicker. I think the problem with a lot of AI sort of messaging today is that quicker is synonymous with dumber. Nobody wants dumber, everyone wants smarter. I think that trade-off is shifting. So the third idea I want to present to you is code-based understanding. This is the most recent ship I worked on 2 weeks ago called Windsurf Code Maps. I really like the tagline. I think we came up with it as a group, so I can't take credit. Understand code before you vibe it. And I think that is the key distinction that I really want to portray. I should probably try to demonstrate to you what this looks like. Basically, it is a specialized tool. It's not a coding agent. Specialized tool for you to understand your code base better, whether a visual map or a sort of tree-like hierarchical description. So you can see it online as well. And here's a link to it. And it ties to your code base. So here I'm sort of navigating around the code base. It's annotated, and it jumps to the different files. If I want to switch to a visual version of it, it explains to me the actual flow of code. And I found this particularly useful if you cross system boundaries for code execution. For example, front end to back end, or you have some amount of number of systems that you're jumping back and forth and distributing work to. So that's code maps in a nutshell. You can go try it. But really, the main insight that I have while working on this was that the further you are from code, the more chance that slop will get in there, right? Pre-AI, everything was human. You had the intent to write code, you read your code, you think about what code you want to write, then you write the code. Then we jump to full self-driving, where the agents just take over completely from reading to thinking to writing. I think what code maps introduced is this nice rainbow pattern of blue, red, blue, red, blue, red, where humans and AI are working together, right, to generate the code. Or if you don't even want ultimately, because code-based understanding is so important, once you're done reading, you actually know exactly where to go. You can just click into it and just edit it yourself, right? You don't have to run everything through a 10 trillion parameter LLM. So that is code-based understanding. And I think those are the three ideas, right? First of all, interactive planning. Second of all, what was the second point? Second point was about speed and flow window. And third was about code-based understanding. And all these are strategies in which to sync the mind to the machine. And I think the extreme of this, I want to take you all the way to the end, is for the real-time syncing human to AI mind meld. Basically assume universal basic intelligence. I also call this big token energy, all right? Let me do the math, right? Humans probably won't change in the next 1,000 years. These fundamental ratios, right? Your typing is 40 words per minute, your reading is 200, speaking 150, listening 300. Have you actually done the math on what that translates to if you just had AI on all the time, at all times, even when you're sleeping? So I did the math. Text, 150 times 60 times 24, is actually 200,000 tokens. Your entire day's worth of typing and speaking fits into the context window of one of these models right now. Costs 9 cents to process, 9 cents. Voice, 1,440 minutes per day is charged per minute, so it's about $4 to $8, depending on what model you pick. I went ahead and did vision. Vision is the most expensive one. 1080p at 1 frame per second is roughly $750 if you pick the cheapest model, to $200 per day, right? Basically, full multimodality sync is $12 and up. $12 for the beginner tier, more if you want to pay more premium. You can just leave AI on to sync your brain to the AI. Why don't you, right? This thing, by the way, this cost curve is going down roughly about 50 to 100 times per year, right? This is much, much faster than Moore's law. So I think those are the main mental models and frameworks I wanted to leave you with. There's a few last principles I couldn't figure out where to fit them. These are just sort of UX, UI principles that we're thinking about. It hasn't shown up in the product yet, but it's going to show up soon. One, get rid of buttons. No buttons, just always on, right? Challenge yourself to design the UX with no buttons, including no send chat, right? ChatGPT with the send chat probably is suitable if you're trying to save tokens, but when it's too cheap to meter, you don't have to. When you have big token energy, you don't have to. Use vision. Vision is basically solved. Voice is not. Vision is basically solved, so use vision a lot, right? And then finally, never block input, right? Try to just always let the human express themselves whenever, and never block the input on the AI, because the human is always more important than the AI. Thank you.
Awesome presentation. We have a few minutes for questions. Who wants to go first?
So, about your point about no buttons, I've also seen some advocates advocating for hybrid AI, like UIs, where like you have some buttons for the human to use, and then the AI is just also editing and doing stuff. But
Yeah.
like humans, you like buttons, right? Like
Yeah.
we've built the buttons for the
Affordances.
people. And so how do you feel about that? Like UIs like Notion, for instance, which might use AI, but also still has buttons, but you know, you're working on the same canvas.
Right. So I think then the buttons kind of substitute for signals that you're sending, and probably in most UIs, you can probably find in another analogy or interface that triggers that, including lack of action. That is also a button. So yeah, I mean, obviously put buttons in, but like I think like maybe the modification or the less spicy version of what I said is don't only trigger AI inference when someone has clicked a button. That seems like an artificial rate limit because you're trying to save money. Actually, it's pretty cheap. If you just leave it on, it's like $12 a day. That's the yeah.
So I'm a little said here that using AI, people feel more productive, but in general are 20% less productive. And I believe you, although I've seen the same studies. Why is everyone still doing it? And I'm not like, I use it some, and I'm a believer in aspects of it, but I'm a little like, I'm struggling with this cognitive dissonance of the studies show that we're lying to ourselves about how much they help us. And yet all of us are here like, obviously we're all going to do this all the time for everything all the time. So can you help like close that loop a little bit?
Okay. So I think there is some cynicism here that is warranted and some that is not. Where's that study? Oh yeah, here it is. So basically, some people are good. Many are not. So this is something I didn't cover in the talk, but if you actually break out the individual developer audience, individual developers in the study, some of them actually did improve, and a lot of them did not. But I think over time, those more and more developers will move into the green. That's one. Two, we all here are early adopters. Like literally, by definition of being here, you are an early adopter. So we just want to taste the future, and like obviously this will get better every single year. And so we want to be a little bit ahead of the trend. I think three, there are actually parts of the tasks here. This was on very highly cognitive demanding tasks in open source, right? But there are a lot of bullshit tasks in development. Like make this button bigger, add another thing to this list that I can delegate to the AI right now, today, to Devin, and it works, right? So like, I think there's just a range of tasks. 70%, let's say 80% of our jobs are just routine. We know how to do it. It's boring. It's automatable. Let's delegate that. And the rest we can start spending on more important tasks. So I think that basically the shift in the quality or the challenge of work is not well reflected by these kinds of surveys. So I think we can theoretically feel it. Some of it is probably unwarranted optimism, and I try to reflect that in my talk, right? Like some of these guys, people like get overhyped about their excitement, but some of it is warranted. And I think over time, like definitely, I myself has felt a step change from 2022 to 23, 24, 25 of like how much it is really accelerating and helping me. It's just very hard to measure. And actually, I think it's probably when the data and the humans disagree, we should probably trust the humans. You know what I mean? Like I know we distrust humans a lot because humans lie. But overall, I think when our skin is in the game, when it's our choice of tools, and we consistently keep choosing those tools, trust that the humans are making the good choice, and like figure out what in the data we're not capturing. Because these surveys are very primitive. We don't know how to measure developer productivity.
Let's give Swix another round of applause.